The GEMS-413 is gaseous effluent monitor with particulate and iodine sampler designed to monitor gaseous effluent from the ventilation stack of a nuclear power plant under accident and post-accident conditions. Maximum particulate and iodine sampled activity by GEMS-413 is 1 terabecquerels. The NGD13 noble gas monitor measuring range is from 300 megabecquerels per cubic meter to 5,100 terabecquerels per cubic meter for xenon 133, which exceeds the US NRC Regulatory Guide 1.97 requirement. The GEMS-413 monitor meets the following international standards for air sampling and measurement. The GEMS-413 monitor meets the following international standards for nuclear safety qualification. Electromagnetic compatibility is provided as standard. IEC standards corresponding to the IEC 61226 standard requirements compliance is provided on request. The GEMS-413 monitor consists of 2 redundant particulate and iodine samplers with exposed filter dose rates detectors, radioactive noble gas detector, harsh condition sample heat exchanger and condenser, air pump and airflow rate controller, heat traced sample line with thermal insulation and local process and display unit. The remote control and display unit is located in the main control room. The GEMS-413 in post-accident operation mode perform particulate and iodine sampling and noble gas monitoring. The particulates and iodine are separated and collected by particulate filter and silver zeolite cartridge in tungsten and lead shielded sampler. Dose rates from exposed filters in both samplers are monitored. The sample temperature and humidity are reduced in the heat exchanger to 50 degrees Celsius and 90% humidity, and excess water is condensed into the collection vessel. The radioactive noble gases volume activity is measured in the NGD13 noble gas detector, and after that air sample is returned to the ventilation stack. The GEMS-413 allows to purge particulate and iodine samplers, noble gas detector and the input part of the sampling line from ventilation stack with pressurized clean purge air. The pressurized clean purge air with maximum pressure 150 kilopascals is bring on purge air inlet. Maximum purge air pressure is checked and air with higher pressure is not allowed into the monitor. The purge air is returned to the ventilation stack. The GEMS-413 main components description follows. The GEMS-413 has 2 particulate and iodine tungsten and lead shielded heated GES-10 samplers. The process of the new filters exchange is shown on instructional video. Follow the marked direction of airflow when the iodine cartridge is inserted into tungsten container and yellow mark when container is inserted into sampler. Secure the inserted filters with securing lever. Air sample is divided by isokinetic splitter and active sampler is selected using 2 motor ball valves. The sampler switching is automatic based on sampling time, sampled volume, and sampled activity. The total sampled activity on exposed filters is measured by dose-rated detectors placed in samplers. Maximum sampled activity is 1 terabecquerel. Particulate filters and silver zeolite iodine cartridge are used. The process of replacing exposed filters is shown in the following instructional video. The purge of sampling lines and chambers, heat exchanger and noble gas detector before filters removal is automatically executed to reduce contamination risk and operator personal doses. Exposed filters dose rate is recalculated on value of dose rate for worker changing filters with manipulator in 1 meter distance. GEMS-413 indicates if safety dose rate threshold for filter exchange was exceeded. The trolley with installed 30 mm thick lead shielded container for exposed filters and the handling rod for remote filter manipulation are used. The tungsten shielded sampling container with exposed filters is transferred into container on the trolley with manipulation rod and transported to the laboratory. The saturated harsh condition air sample with a maximum temperature of 95 degrees Celsius must be cooled down. The temperature and humidity are reduced to 50 degrees Celsius and 90% relative humidity in the heat exchanger and condenser. Condensed water is collected. The process of condensed water removal is shown on video. Maximum volume of condensed water is 2 liters. The NGD-13 high-range noble gas detector with measuring range from 300 megabecquerels per cubic meter to 5,100 terabecquerels per cubic meter is used. Temperature and pressure sensors are used to recalculate measured volume activity to the standard conditions. Self-absorption correction is applied. The NGD-13 transfer calibration using cesium-137 solid sources is shown on video and on the summary. The air pump and airflow controller are used to provide air sample flow up to 300 liters per hour. Airflow is recalculated to the standard temperature and pressure conditions. Low diameter piping and low sample flow rate are used to reduce total activity in the GEMS-413 parts. The sample line heat trace control switchboard and the main switchboard are installed on the GEMS-413 and GEMS-311. Local processing and display unit is placed on main switchboard. The remote control and display unit is installed in main control room. The GEMS-311 inlet contains isokinetic splitter for post-accident sample for GEMS-413 and therefore it is heated and thermally insulated. The GEMS-413 can operate post-accident and harsh post-accident conditions. It remains in standby mode during routine conditions. The GEMS-413 post-accident monitor and sampler can be used together with the GEMS-311 routine monitor and sampler for routine, post-accident and harsh post-accident conditions monitoring. The GEMS-311 in routine operation mode provides proportional ventilation stack sampling, low-range particulate and iodine sampling, a low-range radioactive noble gas concentration monitoring. The air sample with maximum temperature of 60 degrees Celsius is taken from ventilation stack by shrouded probe and fed to the monitor inlet through the sampling line. The particulates and iodine are separated and collected by particulate filter and charcoal cartridge and sampler. The radioactive noble gases volume activity is measured in the NGD-11 noble gas detector, and after that air sample is returned to the ventilation stack. The GEMS-311 and GEMS-413 are in post-accident mode in post-accident conditions. The air sample with a maximum temperature of 60 degrees Celsius is taken from ventilation stack by GEMS-311 pump and the air sample is bypassing its particulate and iodine sampler and noble gas detector. When the volume activity of air measured by NGD-11 detector of the GEMS-311 exceeded the preset value, the automatic transition to post-accident mode is initiated. High active sample is rerouted to the GEMS-311 bypass to provide proportional ventilation stack sampling. The GEMS-311 used particulate and iodine samplers and NGD-11 noble gas detector are purged with clear pressurized air. The GEMS-413 automatically switches to post-accident mode and provides sampling of highly active particulates and iodine and high-range monitoring of noble gases. The GEMS-311 and GEMS-413 are in harsh post-accident mode in harsh post-accident conditions. The both NGD-13 or NDG-11 noble gas detectors can be used for noble gas monitoring based on gas volume activity. The NGD-13 for high-range monitoring is used in the first example. The saturated air sample with a maximum temperature of 95 degrees Celsius is taken from ventilation stack by GEMS-311 pump and the air sample is bypassing its particulate and iodine sampler and noble gas detector. The particulates and iodine are separated and collected by particulate filter and silver zeolite cartridge and heated shielded samplers of GEMS-413. Dose rate of exposed filters and cartridges is measured. The maximum temperature and humidity of harsh condition air sample must be decreased to 50 degrees Celsius and 90% of relative humidity in GEMS-413 heat exchanger and condenser. Condensed water is collected. The radioactive noble gases volume activity is measured in the NGD-13 noble gas detector of GEMS-413 and after that air sample is returned to the ventilation stack. The NGD-11 for low-range monitoring is used in the second example. The saturated air sample with a maximum temperature of 95 degrees Celsius is taken from ventilation stack by GEMS-311 pump and the air sample is bypassing its particulate and iodine sampler and noble gas detector. The particulates and iodine are separated and collected by particulate filter and silver zeolite cartridge and heated shielded samplers of GEMS-413. Dose rate of exposed filters and cartridges is measured. The maximum temperature and humidity of harsh condition air sample must be decreased to 50 degrees of Celsius and 90% of relative humidity in GEMS-413 heat exchanger and condenser. Condensed water is collected. The radioactive noble gases volume activity is measured in the NGD-11 low-range noble gas detector of GEMS-311, and after that air sample is returned to the ventilation stack.